So first off, good afternoon. Thank you very much for being here. I know there's lots happening in parallel, so I do appreciate you taking the time to listen to me speak for the next 45, 50 minutes or so. Before I start, just a couple of notes. I just wanted to thank the organization. It's my first time here in this event, and it's very impressive, very good, very cool. The second is that, you know, this is not a completely packed room, but it's still quite a few people, a little bit intimidating, and despite you guys intimidating me a little bit, today is my first time that my wife is seeing me do my work, so it's extra extra pressure. You guys intimidate me, but hey. And lastly, I wanted to thank the colleagues at Bosch sitting here who helped me put this together. Okay, so what I will tell you about today is how to communicate, or my advice on how to communicate complexity with clarity. And in the context of modularity. And so I want to pose the question to start off: what good is a modular system if the people that are building it are not aligned? So I highlighted 3 words here: modular, people, and aligned. And these are the 3 key things I will talk about today. So modularity, people, because they make things, and aligned in terms of being aligned. So how do you get aligned? You talk. I will try to convince you or persuade you by the end of this talk that complexity, one of the most important tools that you might have to deal with complexity, is clear communication. And I will try to do this by making 3 associations. The first is that complexity calls for modularity. It's not the only way you deal with complexity, but it's definitely a very good way to deal with it through the divide and conquer principle. Then that modularity calls for clear interfaces. So if you want to build a good modular system, kind of hard to do without being really clear on what your interfaces are. And finally, that if you want to have some clear interfaces, you better have some very good communication in between the teams that are responsible for the modules. I can't start this without getting on a kind of an even footing, putting everybody on an even footing. I wanted to try to make this as accessible as possible for everybody. And so 3 key concepts I just want to introduce. One is modular design, which is just a design approach that says that instead of designing a piece of technology, whether it be a circuit or a software function, specifically for one product in a given portfolio, you design it to serve as many products in the portfolio as possible. So you try to focus on modules and then have reuse of these modules. One very popular instance of this design approach is Volkswagen's Baukasten for the electrical vehicles. So, you know, Audi, Skoda, Volkswagen, and so on. If you have any of these cars electric, they all share the platform. So the Volkswagen engineers worked on these modules, and so if you buy a car, these cars are going to have these modules instantiated in there. They're going to customize, they're going to look different, of course, but inside there's going to be some modules that are very common. A module is just a piece of technology that serves a particular function within a modular architecture. Here, I chose a compressor within a heat pump because heat pumps is what I work on at Bosch. And then a modular interface is just the connection point between each of the modules and also with the external world. So let's tackle the first topic. How does modularity help with complexity? Now, I don't have to tell anybody in this room, I think, that complexity is sort of exploding. We have very complicated products nowadays, and we have many sources of this complexity. And so why does it matter? Well, I'll tell you about my source of complexity, so the things that worry me, even though for you it may be something completely different, depending on the area that you're working on. For me, for heat pumps, one source of complexity that's really big is Internet of Things. So the more interconnected systems we have more interconnected systems than ever before. This is great because it allows us to get data, and this allows us to really learn about our products in the field, but at the same time, it does raise concerns about security and privacy. Another big source of complexity for us is the ever-changing landscape of requirements and legislation. Something you may not know if you're not tuned into the energy market, let's say, is that, and this surprised me when I first joined this group, is that every country has their own particular preference for things they want to see, functions they want to see in their home, in their heating. It's very different. I would expect us all to have a shared experience, but no, every country has their own way that they want their heating system to work. And also legislation. We kind of want to get away from our dependency on natural gas, because who supplies natural gas is Russia, and so Europe is trying to get away from this supply of natural gas. But this legislation is dragging, and the more you drag, this influences the number of heat pumps you want to manufacture. And if you're manufacturing 100 heat pumps per year, that's very different from manufacturing 100,000 heat pumps per year. You should have very different design principles, very different concerns. And finally, the enhanced configurability of our devices, of our appliances. It does mean enlarged use cases, so it's just more things we have to think about, more testing coverage. It's a big challenge. And another one, which is more on the human side, is the increasing, a lot of you will feel this, you'll know kind of what I mean. There's increasing cross-border developments, some cultural differences and expectations. Informal communication, of course, not as easy, and you don't even have to go outside of your country for this challenge. I mean, some of us work fully remote, and so you have this thing as well. Informal communication has to be sort of planned, which is a bit, yeah, but it works eventually. Then we have distributed decision-making as well, especially with modular architectures. You don't have one person saying exactly what this thing is going to look like. You have varying developer maturity levels. I'm sure everybody also feels this. So unless you have a really airtight process, you're going to struggle with this in some way or another. And virtual trust is still a challenge for people. So if you work with some team in Iceland, you've never met them, you've never spoken to them, you don't really know if you can trust their design instinct and how they think, basically. So why does modularity help us? How does modularity help us here? Well, it gives us agility, and that's the principle for the Baukasten, so for Volkswagen's Baukasten approach. You are able to make smaller, more contained changes and adaptations, customizations to each module. You can scale much more easily. You can do modular refinement across different use cases. So the same for this, if you think the electric drivetrain, it's different if you're putting it on an ID3, Volkswagen ID3, or maybe an Audi. People are going to be different. They're going to use the car in a different way because of these different brands. And that just feeds into your data, and it really helps you find edge cases where you might not have found otherwise. It builds robustness. And then, of course, modules do generate focus. So if you have a module for a thing, you have a team that's working on this module, they are focused. So they can go in depth, which generates depth of knowledge, which hopefully over time translates to cost savings, optimizations, and so on. And then, if you design your system right, so this is not guaranteed, but if you design your system right, you can expand. You can expand your module or your platform by adding new modules. And it impacts collaboration quite a bit, because if you have modular systems, this means that teams will be responsible for their modules, but some functionalities might need 2 modules or 3 modules. And so there's going to be kind of a gap in responsibility or an unclear responsibility. And so the interfaces are where things can go really wrong. Of course, you could say that, it's the system engineering guys that should do this. It's the system engineers that should put the modules together, and they worry about all this stuff. Well, yeah, but they can't be on top of absolutely everything. And I will have some cases here where I'll try to illustrate this point. I bring you an example from Bosch of how we do this in heat pumps. So we basically, as I told you, different markets call for different features, functions. So we create like heating, kind of a simplistic example, but still. You break this down into then level 1 system functions. You break these down into logical elements, and so now you know what you have to build your product portfolio. Then there's different types of product, so you can think of these as like different architectures of the heating solution. And we know we want to serve these because the markets kind of want this. It's kind of different use cases in some way. And then we allocate the logical elements and we create products. So we create boxes that do things. And we have not yet, so we know what it wants to do, but we haven't specified what they're made of yet. So that's in the third stage, when we then create modules. And then we close the loop by looking back and seeing, okay, what does this module need to be and do to serve all of this stuff? It's a big challenge, and one we still tackle. Still from Bosch, just to give you an idea, basically it's a heat pump with a tank. And you can see the different colors show you some of the modules that we have, where I'm particularly interested, I'm an electronics guy, so I'm particularly interested in the green one, which is the control box. It's going to have a screen, a display that you can interact with. And this display is actually also a module. Not only the control box is a module, but the display is also a module. So you can use this across different products. Control box, the same thing. And so if you think about control box as behavior, so you have to have something that can implement all the behaviors that I showed in the previous slide. Okay, so it's an approach that is quite successful, and for Volkswagen's case, it's worked pretty well, and for us too, if I have to say, in terms of engineering efficiency. Then modularity calls for clear interfaces. So if you really want to build a successful modular product, you need clear interfaces. And I'll give you an example for how these interfaces, how this can go wrong. So I'm going to present a few examples here. You'll notice a trend. A lot of them are space related, but I think it's not an accident. It's just that space technology doesn't work agile necessarily. So you it does, but your PIs are a decade long. And basically what happened is that in 1999, we had the Mars Climate Orbiter. That was a mission launched. NASA coordinated this. They contracted Lockheed Astronautics to build the rocket, to build a spacecraft, and then they were in charge of the trajectory, of the flight control, basically. So, you will have probably heard this story. You might not know details, but basically, Lockheed Martin, being an American company, these guys were using the imperial system. So to calculate impulse that's needed for you to, you activate your thrusters, and this is going to take you somewhere based on the equations, the movement equations. And these guys were using the imperial system for the variable of impulse, whereas NASA was using the metric system. And so guess what? It's like driving a Lamborghini that you don't really know how to drive. You just press on the pedal and all the power goes in, and this thing crashed immediately. And it was interesting that this was in the specification. So these guys actually put metric units in the specification. I think it's interesting and commendable that NASA to this day still says it's their fault. Yes, these guys didn't fulfill the specification, but it's their verification process that failed. Yeah, you could have all this stuff, but had this been communicated clearly and expectations set very clearly, had the teams worked more closely together, maybe this could have been avoided. So communication is actually what holds a system together. So what holds a modular architecture together. The modules or interfaces are what makes a modular product come alive. You have all these modules, but then if you want to make something that does something for a user, you need interfaces. And these typically are if you want to deploy a feature, when you think from a system architect perspective, you design a feature, and your feature is going to touch on a bunch of modules. So these modules need to work closely together. And when these modules are of different natures, it's not very easy. So I'll give you an example for me that's relevant for me. I'm, like I said, an electronics software guy, and so I have to talk to the team that works on the compressor. These are mechanical engineers. What the hell do they know about what I'm saying? They don't really understand. So I have to, and I don't understand them either. They want to talk about thermodynamics. I want to talk about just behavior, just control. I want to know what signal comes after the next. And engineers, I think, like kitchen chefs, they, if you think of these kitchen chefs working on a dish, each of them working on, or contributing parts to a dish, the dish then goes to the customer. It doesn't matter if you've made the most fantastic puree or something. If the steak is burned, that's what the customer is going to remember. So the product is only as strong as its weakest element. And in terms of, you could say, okay, yeah, but still, it's the system architect that should worry about this. It's the system engineers that should worry about this. To dissuade you from this point, I just showed you the picture that's a visualization of Amazon's microservices interdependencies. This is from 2008, so this is almost 20 years old. How can someone untangle this net, this web? It's really challenging. But the reality sometimes, most often, when you have such a setup, is that you have these system or architects in the ivory tower way up there. Then you have these tiny groups of people that are building the modules, and they get handed this blueprint from this person up in the ivory tower who does not understand their challenges, maybe, really their functional challenges, and they don't understand necessarily what this guy's thinking. So there's a disconnect here that we must somehow bridge. It is, I would say, dangerous to expect system architects to do basically everything. It's way more scalable if you build this from the bottom up. So if you have the teams orchestrating, talking to each other, understanding their differences, so that they can have a more informed discussion, maybe even with a system architect. So next, and this is where I want to spend most of my time, clear interfaces call for really clear communications. What is this clear communication? I bring you another case where this goes wrong. This one probably many people have heard of. It's very recent. There's a whole documentary about this. I think it's called Downfall or something. And it's about Boeing. And I called this, or I titled this, technically correct, but functionally misleading. So they did communicate. They did communicate. Boeing introduced this MCAS system, and I have to go to my cheat card here to read it. It's the Maneuvering Characteristics Augmentation System. So if you can immediately understand what this does, great. Most pilots, at least, had no clue. So this was a system that basically, these 737 MAX airplanes, they had new engines from the previous, let's say, generation of airplanes, and they were more powerful. So when you put thrust into them, the nose would tilt up, and so this called for a system that adjusted the tail as to push the nose down to correct for this extra kind of tilt. They introduced this, and they put this in the manual. They said, oh, we introduced this MCAS system, but the information was incredibly sanitized. If you're interested, I suggest that you dig this up. There's more to be said. Some statements may be a bit controversial, something to do with Boeing's culture and so on, but these people, maybe it was intentional, maybe not, it's hard to know, but they sanitized this information, and so pilots actually had no idea what this thing did. And to make matters even worse, this is one of the only systems that in aviation that didn't have redundancy. So to see whether or not to trigger this, there's an angle of attack sensor, and typically in aviation you have more than one sensor. You have redundancy, because so if things fail, you still have a backup. Here, no backup. So if this thing failed, if this angle of attack sensor failed, and this happened twice, as the planes were taking off, this MCAS system would kick in and the plane would kind of tilt down. Pilots had no idea what to do, so what do? They're just like, oh, something's going on. I'm going to tilt this up even further. That just made MCAS even angrier, tilting the nose further down. And this led to 2 big crashes with 346 fatalities. So this was, of course, there's a lot of corporate blame to be tossed around here, but they did communicate this. They did make an effort to communicate, but they were just not clear enough. Another case of maybe I think this case is more what we're more used to. I think the people in this room, this might be more familiar. And this was, or it might resonate with you a bit more. This was the Columbia Space Shuttle disaster. This was in 2003, I believe. And what happened was that engineers had a call with management at NASA. And the engineers, in a 28-page slide deck, they showed this slide. And I read a blog post that was it was a bit harsh on maybe, I don't agree with the statement, but the person who wrote the blog post said that this is the PowerPoint slide that killed 7 people. I think that's a bit harsh. You can't really blame it on the people, but you can see how it contributes. So this slide says, review of test data indicates conservatism for tile penetration. Maybe you should expect NASA managers to understand what the hell this means, but clearly they didn't. And it's the way that this is structured. So this is very engineering-like. This is like, I don't spend time in formatting, and I don't have time for this. I just focus on content. Well, look what happens. This is like all these levels of indentation, so it feels like everything is related to the point at the top. And all the points here, except for this last one, they're kind of positive. So they go, yeah, this seems like it's going to be fine. They were worried about structural integrity of their thermal tiles if they were impacted by something. And so they said, oh, according to our test data, based on what we have, seems like it's fine. It's going to maintain its structural integrity. But then at the end, they wrote, flight condition is significantly outside of test database. What does this mean? It means that the tests that they had performed, that they were basing their analysis off of, it was completely outside. The flight data was much more severe. Guess what happened? As you can see in this GIF up here, a little bit came loose as the aircraft was leaving Earth's atmosphere. A little bit came loose and struck a tile. And this compromised the structural integrity. What happened? As the space shuttle was coming back, as the spacecraft was re-entering Earth's atmosphere, it fell apart. So it lost its structural integrity and fell apart. The point I want to make with this is speak louder. Speak louder. Are you concerned? Speak louder. Make your point heard. And yeah, they had this meeting and they walked away, probably high-fiving each other. The managers were like, we're good to launch, we're all good to go. And the engineer said, yeah, they kind of understood that there's a risk here. Yeah, they didn't. And then the final example I want to bring is the fall of a company called Knight Capital in 2012. This is one of the most recent cases, and to show you it's not all spacecraft. It can also happen elsewhere. So what happened here was that there was this Wall Street trading firm who had, they were involved in Wall Street, of course, and they wanted to issue a software update to their system. And they did this manually. So there was a technician that they had 8 servers running in parallel, and this guy went in and updated the software. He was meant to update the software in 8 servers. But he's human, so he failed. And he failed, and so he only updated 7 out of the 8 sensors. Thing is, this software update repurposed, I think a lot of the senior people in software development here are going to cringe a little bit, but this new software update repurposed an old flag that was used for a different function. So they went, oh, this function is deprecated, it's not used, let's just repurpose this flag. And as they updated all of the servers except for one, as this came live, what happened, unfortunately, this deprecated function that they repurposed was a block trading function. So a function that would start a trade, and it would only stop when it got the command to do so. But the problem is that none of the other servers knew of this. None of the other servers had this function because they had been replaced. So in about 45 minutes, 397 million shares were traded. This company was exposed at around $7 billion in trades, and they lost about $440 million in 45 minutes. And they shut it down, of course, but it was too late. A few months later, they were they were financed by investors and then acquired by a different company. They went extinct. This came out. So an hour before market opened, they got an email. A big distribution list got an email saying, hey, we are detecting some anomalous stuff happening here. And because there were no procedures, nobody knew what to do, nobody said anything, everybody just assumed this other guy is going to pick this up. And lo and behold, a crash. The story gets even funnier because at 20 minutes in, they noticed this was happening, so what did they do? They panicked and they went, oh, it's a new software. Let's roll this back. And as they rolled back, all 7 servers now had this block trading function. And now suddenly it's got even worse. So it even accelerated the problem. Again, decision making without proper communication. So, how do we tackle this? How do we do it? How do we actually make our communication a little bit better? I have 3 pieces of advice. So this is not a toolkit, it's not silver bullet, it's advice. One is audience mapping. So consider your audience. Like I did today, I adapted my language so that it would be accessible for everybody. I don't know what your background is, so I tried to put this together in a way that everybody can understand what I'm talking about, hopefully. Second is layered storytelling. I'll get to this in a second. Actually, no. This layered storytelling is, I think there's a great example of this. It's a YouTube series from a magazine called Wired, and I think it's brilliant. So it's a series where an expert on something, or somebody that's known for something, is explaining a thing, a concept, in like 5 different levels of difficulty. So the one I remember the most is Jacob Collier, a musician, a fantastic musician, who explains music to a 5-year-old and also to Herbie Hancock. And the levels of conversation are really interesting, and the message is kind of similar, but at different layers of depth. This can be a really powerful tool if you try to do this. If you actually try to tell your story, the thing you're trying to sell, the thing you're trying to get implemented, the feature, whatever it is, or the bug you're trying to fix, the solution you're trying to push, you tell the same story at different depths depending on the audience that you have. And finally, and definitely not the least important, is feedback loops. Really check that you have been understood. Be deliberate about this. Don't just hope. Don't be like the NASA guys that high-fived each other and thought that everything was fine. Do something about this. Thinking of the audience, I would say roughly there's kind of 3 major levels of audience, of people, types of people at a company, typically. You have the strategic people that just want to know why we're doing this, and they want to see what the value is of this activity. You have the tactical people that really care about how you're doing this, what you can expect, what timelines are we looking at, and so this is what these people are going to be sensitive to. And then finally, the technical side. So this is where the detail comes in. And I don't know if I've got time. I'll tell you a personal story of mine where I failed miserably at this. So this was 2011. I was doing Erasmus in the UK, and I was finishing my dissertation, and I was presenting my dissertation. I was doing something with robots and getting robots to look at obstacles, detect obstacles, avoid them, identify them, and for some reason, at the time, I had this huge challenge at some point with identifying the color yellow. I can't explain it. I think it was down to that particular robot that I was using, but I just couldn't. I was really struggling with identifying objects that were yellow, and this ate up so much of my time. And I was like, "What's happening here?" As I was presenting my thesis, I had like 20 minutes to go, or to present, and I remember starting to get into my presentation, and then I started talking about the challenges with identifying yellow. And I went on and on and on about this, and I remember the professor at the time who was sort of supervising me, he told, "Hey, you've got 2 minutes, wrap up." And I was still talking about yellow. And so what happened is that I had to rush through the rest of my presentation, and guess what? My message just landed completely flat. The thing I wanted to talk about just landed flat. And I think us as engineers, we do this very often. We talk about the thing we want to talk about because it's the thing we're interested in, it's the detail that we're interested in, and we really want to, like, we go through the events chronologically. And so there is a benefit in thinking about your audience and structuring your story. I learned this lesson the hard way. Still got through, but hey, could have been way better. So some very, I would say useful tips, useful tips on how to communicate a little bit better than you currently do. One is to visualize, and that is to step back. So for me, it's like visualize what you're trying to tell, the story you're trying to tell. Does yellow matter? Does the different difficulty in identifying the color yellow matter at all in this thing you're trying, in this thesis you're trying to build? No. So don't dedicate time to it. Visualize. See what it is that you're trying to show. What would a one-pager look like? At Bosch, managers love one-pagers, and it's kind of pain in the ass to do, but it does have its benefits. Then simplify and layer. As I've mentioned before, try going through your cycle at different depths, and at every stage you add a little bit more detail that you know some kind of person is going to enjoy. If you have these people in the audiences, in your audience, this is for them. Then tailor. So keep really only the parts that they will understand. If you are talking about something that your audience will really not know what it is that you're saying, just don't have it. Be open to questions. I think we as engineers very often like to be factually correct. So we really are passionate about putting everything out there so that it's a foolproof argument. I said this is how it should be. But you actually have to make sure they understand your point somehow, that they have the capacity, they have the technical know-how, they have the context to really understand what you're talking about. And again, last but not least, confirm. So do this actively. Whether it be have a conclusion, spend some time asking questions. Don't be afraid to say, did you get any of the things I was trying to say? Did you get my point? Have them repeat their point back to you. Yeah, I get it. You shouldn't do this all the time because it gets annoying, but do it strategically. And make sure, especially when it's important, make sure that you're on the same page. And communication, I think it's like, within engineering, it's a bit frowned upon, like I said, because people like to focus on the content. The more simplistic the information is, the less time you dedicate thinking about the formatting of your things, the more true to engineering you are. And yeah, I'm not saying take time away from content building to actually worry about the form. No, you still do your work, do your due diligence, but dedicate a bit more time and give a little bit more relevance, a little bit more care and respect for making the message land, making sure the message lands. It is, for leaders in particular, I would say there are ways that you can instill this in your team. So you can worry about stakeholder management. If your team is working on something, make them think, who should know this, 100%, and who could benefit from knowing this. And this second point is not often in engineering teams' minds. Who could benefit, just as information. The second bit would be the second piece of advice I would have to give you is instill in your team a wish to do stuff and to talk about it. So instill in the team a wish to put this new thing that they've built out there and get it advertised within the group, within the business unit, whatever it is. Engineers don't like to do this. Engineers are sometimes, they think this is like calling for attention, or it's like, oh, it's me. Sometimes yes, but sometimes definitely no. Sometimes just saying what it is that you've done and the benefit, making clear the benefit of what it is that you've done, is a huge thing, and it's a missed opportunity for the company if you do not do this. And make it a habit to summarize. So a team I built from scratch, which a while ago I built a team from like 2 people to about 17. And the one thing they were all young, straight out of university, very malleable. So I tried they were not offering a lot of resistance to this, and they really benefited from this. They still do it, even though I'm not their leader anymore, they still do it. They summarized. So they do something, and then they summarize. Not as a report, so not as like a 10-page report, or still do that if you have the time, but also summarize it in a way that you can, if somebody asks, you will have a one-pager, or you will have a clear summary of what the benefit is, how difficult it is to implement, something like this. It is knowledge that's more easily consumed. Then encourage feedback. Really encourage feedback. Does your audience understand? Let's say you're a leader and you're talking to your team. Did they understand anything that you were trying to say? Did they understand you're trying to communicate some strategy or some new way of working? Did they understand? This varies across cultures, of course. So some cultures look a little bit, or in some cultures it's a little bit more difficult to speak up and to be honest. And hierarchy, big deal. Other cultures, not so much. So obviously take that into account, but I trust you as leaders to make that judgment. And also think about adjusting. So be open to feedback, to constructive feedback, and do try to adjust. So do try to take on board the things that they say, despite rank and position and so on. Some cultures do this inherently, others absolutely shy away from this. Last but not least, push for module owners. So if we go back to modularity, which we talked about in the beginning, make sure that you have clear accountability. You have clear people that make decisions. All the stuff that I'm saying, I have to say, if you have a process in place, an airtight design process, great. But still have this. The way you get to an airtight process is by having the teams communicate and understanding each other and kind of filling in the gaps that you see. So this does not replace a process, so a proper framework for communication does not replace process, but it enhances it. And if you don't have it, or if your process sucks, use this to improve it. So, I think I'm getting to the end of my time here, and I forgot to time it. I would say make one change this week in this direction. If you're a leader, talk to your team, see how they feel about this. If you're working as part of a modular architecture, reach out, and you have teams that you work with, reach out to them and try to learn from them. What is it that they need? So people that use your work, try to understand what is it that you could improve a little bit that would make their work a little bit better. And do this actively. You know, a lot of us, we join a company and we just assume things are this way, and we keep working this way, and it's been like this for a very long time, so you don't question it. But if someone actually steps out and tries to see, is there anything we could improve, this has huge benefits. Sometimes it unlocks a whole new way of interacting. And it helps other people understand what you're doing, why you're doing it, what are the things that make your life more difficult. And through this conversation, maybe you'll improve your life as well, and you'll improve their life as well. And if you think about the kitchen chef's metaphor, you just get a way tastier dish. This is a phrase that's heard very often in the project management world, where complexity is inevitable, confusion is optional. And if I have to leave you with a parting thought, I would say encourage your teams, encourage your engineers to be noisy and not just polite. So I say just because they still have to be polite, but make them, push them to be noisy. This is how you build better products. And I think that's it. Thank you very much.